Doppler effect with sound. Consider sound waves being produced by a stationary source, an ambulance. The listener is also stationary. Sound waves are longitudinal waves with compressions and rarefactions. The sound emitted by the siren of the ambulance travels in all directions at the same speed. These are shown by concentric circles. The blue circles denote compressions, and the red circles denote rarefactions. The distance between two successive compressions of air molecules is the wavelength of sound. The speed of sound in a medium is constant, so the frequency of sound determines the wavelength. When the waves reach the listener, the wavelength of the sound is the same as the wavelength of sound emitted by the siren. Hence, the frequency of sound heard by the listener is the same as the frequency of the sound produced by the source. Now consider that the source of sound, the ambulance, is moving towards the listener with a constant velocity. The sound waves emitted by the siren of the ambulance again travel in all directions at the same speed. The compressions and the rarefactions can be seen. However, since the source is moving towards the listener, the compressions in front of the ambulance will be closer together and the compressions behind the ambulance will be further apart. Therefore, the wavelength of sound, as heard by the listener in front, will be shorter. The waves catch up with the previously emitted waves. The listener will sense that there are more waves arriving per second than when the ambulance was stationary. This increased frequency is heard as a higher pitch sound as the ambulance approaches the listener. Now, consider that the source of sound is moving away from the listener. The compressions behind the source will be further apart. This happens because the source is moving away from the waves that it has emitted. Therefore, the wavelength of sound as heard by the listener behind the source will be longer. The listener will sense fewer waves arriving per second than when the ambulance was stationary. This decreased frequency is heard as a lower pitch sound as the ambulance leaves the listener. Note carefully that the frequency of sound emitted by the ambulance is the same in all the cases. It is the apparent frequency, or the perceived frequency, by a listener moving relative to the source that is different. Now, we consider that the source is stationary, but the listener is moving. If the source is stationary, and the listener moves closer to the source, he will again hear more waves per second than when he was stationary. The pitch of sound increases. If the source is stationary, and the listener moves away from the source, he will hear fewer waves per second than when he was stationary. The pitch of sound decreases. Doppler effect is experienced whenever there is relative motion between the source and the listener. The apparent frequency heard by the listener, FL, is given by FL equals V plus or minus VL over V plus or minus Vs times Fs, where V is the speed of sound, VL is the speed of the listener, Vs is the speed of the source of the sound. In this chapter, we only consider cases where either the source or the observer are moving relative to the other. The numerator of the formula V plus or minus VL is V plus VL if the listener is moving towards the source. If the listener is moving away from the source, it is V minus VL. The denominator of the formula V plus or minus Vs is V plus Vs if the source is moving away from the listener. If the source is moving towards the listener, it is V minus Vs. If the source is stationary, if the listener is moving towards the source, FL equals V plus VL over V times Fs. The apparent frequency is more than the actual frequency. If the listener is moving away from the source, FL equals V minus VL over V times Fs. The apparent frequency is lesser than the actual frequency. If the listener is stationary, if the source is moving towards the listener, FL equals V over V minus Vs times Fs. The apparent frequency is more than the actual frequency. If the source is moving away from the listener, FL equals V over V plus Vs times Fs. The apparent frequency is less than the actual frequency.
Starting to feel it? Now go master it with Maski.